Right. Hello, everyone. Welcome to my YouTube channel. All right. What are we solving today? So this is the problem statement. It says merge two binary trees. So here is the input. So you have two tree one, tree two, and basically the output should look like, I would spare the time reading this, but basically the output should look like if both tree has a node at a specific point, then basically add them and create new. Let's say over here you see the 4, the tree 2 has it, tree 1 doesn't have it, then we just add 4. So what does that gives you an idea about that? If there is a node, let's grab the value. So 1 and 2. And if there is not a node, then probably consider it as 0, right? So first thing first, let's go and start coding. So sanity check, if both nodes are null, then we're gonna just return it, right? Because there is nothing. So if t1 is equal to nil and t2 is equal to nil, just return nil, right? What is the next thing we're gonna do? So let's just create two variables for t1 node value and t2 node value. So let's call them var val1 is equal to 0 and var val2 is equal to 0, right? Now let's check for t1 and t2. So what are you gonna say? If let underscore t1 is equal to t1, if t1 is not null, basically, if that's what it means, we are basically binding it. If that happens, then val1 is equal to underscore t1 dot val, right? And same thing, if let underscore t2 is equal to t2, then val2 is equal to underscore t2 dot val, right? With that, we managed to grab val1, val2. Let's now create this return. So let's say, what are we going to do? So let's just var root node, okay, and that will be a type of tree node, question mark, right? What are we going to do next? So this, if the val1 is, so what we checked here so far, if both are null, then it's not going to hit the statement, right? So either one of them is not null. So that means if t1 is not null, then it will val1 will have the value, and let's say t2 is null, then it will be 0, right? Val2 would be 0. So this will have some value for sure. So once we created this root node, what are we going to do? We will say that, hey, what's going to be the left of root node? So root node dot, because it's optional, so let's use question mark, left is equal to, and now let's just call this guy with, again, t1 because it's optional dot left, and t2 optional dot left, right? And same thing we're gonna do for right. So t1 right and t2 right, and I think I mistyped here. It's t2. Okay. And ultimately, you're gonna return the root node, right? So what essentially we are doing, we are grabbing the the root of t1, so 1 and 2. So this will be created a root node with 1 plus 2, 3. And we're gonna say what's the left of this new root node. That will be, again, call this recursively with t1 left, t2 left, same thing. We will recreate this kind of node again and kind of return this to the left. So you see how recursion in the stack, that gives you the value. So when this will be called, with this again, it will hit the return statement, and whatever the value will be returned here. So ultimately, the parent root node stack will return the actual root node. Let's try and run it and see if it works, or I mistyped something. Is there any compiler? No, in one go, perfect. So let's try to submit and see what happens. Okay, there you go. Okay, cool. All right, thank you.